So we're going to look at solving exponential and logarithmic equations. So this entire section is nothing about solving these type of equations. So let's start with the first one. Solve 2 to the x equals 2 to the 7th. So this is of the type where, notice, the bases are equal. So what do we notice? Notice bases are equal. And exponents have one variable, could have two. And the function is basic. And what do I mean by basic? Again, this is like the parent function, the basic functions. In other words, all I'm looking at is something like this. That type of situation. There's no multiplying, adding, for example, whatever. Maybe even something up here. But there's nothing else going on with this expression. It's just very basic. So yes, is this as simple as it looks? Of course. So this is of the type, look, I'm trying to solve 2x equals 2 to the 7th. How can I make these two equal? Well, I mean, just visually, I'm seeing that if I make x equal to 7, that's the answer. In other words, that's I've solved it. Now, what this says, again, x equals 7, and what I want you to write as the answer, I want you, so this is also part of your grade, I want you to write. And again, this is just part of the math department protocol. So I want you to write solutions to equations. I want you to write either set notation like this is the set, or better yet, you'll say, look, I was solving for x, and this means given that the answer is a 7. So that's what I want you to write. Again, in quizzes and exams, I will take points off if you don't write this way, if the answer this way. So this is just now stating the obvious, and now we finish writing it by doing this. Let's look at another example. Solve 3 to the x equals 3 to the 2x minus 1. So notice same scenario as above. Now we have variables on both sides, but the same scenario. These are basic functions, except for the fact that I'm doing something to the input variable. But that's okay, because the same thing is true. The only way these two can be equal, just visually inspecting, is if the exponent. So I can only achieve equality if exponents are equal. Just like in example 1. Since, again, I'm hoping you see this, since everything else is the same. On both sides of the equation. Are the same. Okay, so that is the idea here. So now if I have to solve this, then I realize, okay, I'm trying to solve 3 to the x is equal to 3 to the x 2x minus 1. So the only way they can be equal is, again, if the exponents are equal, and now this is just a nice, simple linear equation, I solve that. So notice we went from exponential equation to linear. So all solving processes involve somehow changing it back to a linear form. So once I do that, I can subtract. Again, I'm getting all the variables to one side since it's linear. So subtract 2x from both sides. Again, be careful when you do this. Notice how I'm not writing over this. I'm going to just write another line. I subtract here, and so now I'm going to write the result of this. Subtract, I get -1. Now I'm going to multiply both sides, but notice I'm going to leave this result alone. Then I'm going to multiply both sides by a negative to finish this off. So why am I saying this? I see people getting confused. They start writing over the thing that the result. So they start doing this, and then that means they can't check your work. So this is a good method of, if you do it this way, it's easy to catch a mistake. If you start writing over your previous result, you cannot catch a mistake, and therefore you'll just wind up in frustration. So I get the final answer here is x equals -1 times -1 is 1. So again, I don't want you to finish it off. As a matter of fact, ideally, this would be what I want you to write. Solution set is x equals 1. Okay, so this is just set notation. Let's look at another example, this time with a log. And the same thing applies. Look, it's a basic log, log 3, log 3. Okay, so both sides are exactly the same. Notice the input is sitting before, for these examples, in the exponent. Here they're sitting again inside this log function notation. So inside the input of the log, that's where they're sitting. Because again, this is function notation. This is no different than writing f of x. But now it's sitting here, so the only way these two sides can be equal to each other, the only way I can have equality is if what's inside of them are exactly the same, since the outside is identical. So really, when I look at that, I need to solve the following. Immediately, I see that it's a quadratic equation, so now I'm going to follow the quadratic format. I'm going to subtract this 3x and 4 from both sides, so I'm going to write that down to be clear. When I subtract, I get a 0 on this side, and on that side, I get what you see right here. And now, how to solve a quadratic. The first method you should try is factoring, and all these questions that you're about to do in your homework, you should be able to factor, since that's really what we want you to practice. So I need to find how these two factor. Looking at the 3, it looks like, again, just from experience, 4 and 1, make that negative, make that positive, and then I check. Again, x times x is x squared, -1 times, then negative, again, it's not -4, but I'm thinking it's -4. 1 times -4 is -4. Again, that's not -4 either, but you can see that I'm trying to just play along for the moment. And then check the middle. 1 times x is x. So the middle is the key thing here, checking 1 times x is x. Here, when I multiply, I get -4x. I add them together, and sure enough, I get that middle. So that checks. I factored correctly. And now what I want you to write next, and again, I will take points off, if not a lot, but don't write the answer. Just, I want you to remind yourself that this is what's happening next. You have a product, it's equal to 0. The only way you can have a product and equal to 0 is if one of the factors is equal to 0. So since I want all solutions, I'm going to make both equal to 0. So now I'm going to solve this, subtract 1 from both sides, and I'm going to get -1 here. Again, this is simple enough that I don't need to show me any work. I just need this step's fine. Add 4 to both sides, and here's the result. And now I have my answers, and now I need to check. So you need to check your answers to make sure they are results. I'll check -1 first. And when I check -1, I need to, how come I didn't check above here? Well, remember, what is domain of an exponential? It's everything. So I should check also, but the issue is the domain here is everything, okay? And because it is everything, I'm assured that if I didn't mess up, the answer I get is going to work. But this is not true of the logs. Logs have a restricted domain. The domains of the logs are, so which the basic log, the domain is 0 to infinity. So is it possible to produce an answer that doesn't fit into this narrative? And the answer is yes. Yes. And again, I would have to also get into more of the issue of like, wait a minute, remember, this is a composition. So as well, so you have the domain of the log here, but really we talked about compositions. The thing I'm composing with has a domain of all real numbers. So that means that I'm now faced with just the domain of the log as a main problem. But I check anyway. So 3 times -1 plus 4. So is it possible to come up with an answer here and it's not correct? And the answer is yes, it is totally possible. Meaning it doesn't work. Yeah, this process doesn't guarantee an answer will be correct. So I need to check, and I got 3 times -1 is negative. 3 times -1 is -3, plus 4 is a 1. And again, log of 3, 1 squared is, so that checks out. Notice the inputs are both positive. It's in that domain. I'm happy. Let me check the other one. Check. Okay. X equals -4. I need to check that as well. And I think I'm going to be okay because one thing that's happening, I see that everything's going to be positive. The issue is, can I get a negative number out of here? And I don't think so. So I got log of 16 on this side. 3 times 4 is 12. Plus 4 is 16. And again, I have equality. What's log 3 over 1? Some number, but the same number on the other side. So yes, it checks. So the solution, there's 2 solutions here. It's going to be x such that it's going to be 1, and it's all going to be 4. So there's 2 solutions to this right here. So again, what he knows about the situation, solving basic functions. And all that is required is to make inputs equal. But in order to recognize that, you need to recognize what I'm talking about. So again, this is just a basic function, log 3 of something is being composed, but on the outside part, it's simple, right? I'm not transforming the outside. I am transforming the inside, but then that's okay because the outside is nice and clean. I don't have to worry about that. I can just make the inputs equal to each other. Same thing here. The outside part is all basic. The inside, the input part, again, this is for the exponent. This is your input part. That's a little more complicated, but that's okay. I can work with that as long as the outside part just seems basic. So that's what you want to notice.